Now, this does work. I have to do it like this.
Like that.
Yeah. And hold this for let go and let go. I'm saying I can't. Yeah, you got to record this class. So it's being recorded now. Yeah. Okay. Sorry for the delay, class. Uh, Can I get your name again, young man? Your last name? Mr. Simpson. Yeah, okay. I saw your name on this thing there sometime, but I first time seeing you. Welcome. Uh, we're going to get started. Uh, we have a lot to cover today. Well, first I want to congratulate all of you wonderful students who won those prizes today. All of them. Give yourselves a hand. Very good. And you earned it. That's the thing, you know. You earned it. So, congratulations for winning your prizes today. And Mr. Holloway, he walked away with that 50-inch TV. Yeah. All right. So, we're going to go and do a little quick review of, well, first thing I want to do is let everyone who has those meters to get familiar with your meter. So, it'll help you in getting started with your meter. All right. For those that don't have meters, what I'm going to do, I'm going to walk around and show you different types of measurements for electrical. Now, this here is a voltage tester. All it does for me is test voltage. It just will let me know that, hey, is voltage present or is it not? That's all I use this for. These are your leads here. And I think you can get these at Home Depot for maybe $10 or so. And then you put it into your outlet. That's what up. If you have power, then you'll see it come up to 120 here. That's 120 what? 1 volt. Volts. Right. Okay. Also, this light will come on. Also, you feel a little pressure when you push it in. You feel a little something. Okay. That's what I like about this. This is a good indicator that voltage is present. That's if you're testing to see if, you know, before you work on something, you want to turn it off. So you use this particular meter. Also, we told the students about the receptacle tester. This is the receptacle tester. And I told you this is very, very, very important if you're doing electrical work and you want to find out if there's a problem with a receptacle or an outlet. All you do is plug it in, and it'll let you know if there's any problems with it. Let's plug this in and see where the lights. These lights will come on. If that red light come on, you know you're in trouble. If these two lights come on, then it's wired correct. And there's a legend here to let you know for the lights, the two lights at the end is correct. One light in the middle come on. It'll let you know it's open ground. So this is very useful. And we'll plug it in and see what we got. All right, what do we have? It's good.
Correct.
It's
No, it's
correct.
on.
Okay, it's correct. Because these two lights came on. I'll let you know that it's correct. Okay. So how many people have a contraption like this? Okay. Y'all got one with your kids today, right?
Yeah, but I had that
You had one before this? Oh, okay, good. Yeah, these are very, very, very helpful class. If you have a problem with a receptacle or outlet, just plug it in, it'll let you know. If it comes up open hot, if you've got an open hot, this legend says open hot means none of the lights will come on. Okay? And what do we mean by open hot, Mr. K? When you hear that term open hot, what are we saying?
Power is on.
Huh?
Power is on.
The power is off. Now, what might be the problem is the power at the circuit breaker, the panel might be on, but it could be that the wires on your screw terminals, this is your hot side of your receptacle here. No short slot, that's the hot side. That's where your black wire or red wire go here. It could be that the wire is loose or broke off. Now, some receptacles, you can plug them in the back. You push in. Sometimes those push-ins will come out. That way, it'll indicate an open hot. You got me? Okay, very good. You know, you can get these $5, $6 at a home. So please make sure you have one next week. If you don't have one, you got. All right. This is the receptacle. Y'all have your meters out. Do you have batteries in them already? For the batteries, okay. But we'll get you started on that as soon as I finish with the young man who's talking about the meters. And I've mentioned this here. The voltage tester. This is primarily a voltage tester. Plug it into the outlet. It'll let you know whether you have voltage or not. That's all I need this for. All right.
What about this voltage tester?
That looks like the non-contact voltage tester.
The one we want.
Yeah, this is the non-contact voltage. This is a voltage sensor. And you just put it up near where you might suspect voltage, and this light, this little light,
Yeah, when you touch the black one,
where your light at?
that's the black thing in the middle. Yeah.
Okay, this light will come on if there's voltage present somewhere. Let's check it out. Okay, that lets you know voltage is present with the beeping. This is called a non-contact voltage tester. That means you don't push it into any receptacles, or you don't tie it into any screw terminals, or you don't have to take nothing apart. It'll just indicate that there's voltage present. All right, this is good too.
It doesn't tell you how much.
No, it doesn't tell you whether it's 120 volts, 240 volts. In many cases, you don't need to know that. All you need to know is it on? So you go to your circuit breaker panel or your panel board, and you turn it off. All right, and then you test it again. To do what? Verify. That's the word I like to hear. Verify. You always have to verify if something is on or off. Verify. Critical. Okay. Now, let's see. What type of meters you have here? This is good. But you have all the different symbols that you need to do the work that you're about to do. All right? You have amperage, you test amps, and this is how you check your amperage on your units. If you're trying to check amps, you plug it into, you're trying to test the compressor, how many amps this compressor is running. These are the wires here for your compressor. The yellow, black, and blue. And you put them in one of these wires. And while the unit is running, the unit has to be on, okay? And you will test the amperage to see how many amps this unit is pulling. Now, how do you know what's the ideal amps that you should be pulling? They usually have it on the data plate here. All right? Every air conditioner have a data plate. Most of it is located outside. In fact, I saw one the other day at a friend's house, and hers, we think, faded. You can't tell almost anything. Only thing I could tell was the refrigerator, the 410A. That's the only thing. Everything else is faded away. But this here, the amps is 11.2. So you should, if you put it on the compressor while that compressor is running, you should get it to about 10, 11, 12 amps. Okay? Now, let me say this. These are running amps. All right? These are running amps. Now, starting amps would be much, much higher. Be mindful of that. When you start a machine, you can start your car. The engine sort of revs up a little high. Boom! And then you know it just calms down, right? That's the same thing with the compressor. And they call that, it's 11.2 and LRA lock rotor amps. Lock rotor amps is when it starts, all right? And it starts, you'll get 61 amps, all right? But that's momentarily. Most momentarily. So it'll calm down to 11 amps. That's what you want. All right? Very good. So this is how you check your amps. And in fact, this one, you don't even have to set it on any particular numerical setting. You just put it on A for amps, and it'll give it to you. Whether it's 600, 300, 400, it'll indicate here. You'll get all your indications here. This is a digital meter.
This is the maximum 600 volt capacity. 600 volt.
Yeah, you have to look in your paper. Majority of them are.
It says it on
The majority of them are 600 amps.
volts.
I mean volts. Yeah. It should say it on your paper. Did you see it in yours?
On the
It's on here?
at the bottom.
How many?
Oh, okay, yeah. 600 volts max. Yeah. So you can't use this in a lot of industrial work, but commercial and residential, yes. 600 volts. I'm not sure about the amperage. You have to look in your paperwork and find that information, the maximum amperage we have. Okay. And then you have your voltage. This is good too because this is AC volts and DC volts. You don't have to set it on either one. Some meters you have to set it on DC, and some you set it on AC.
This one will give you the reading of both.
Yes. Yeah. Because it has both symbols where your voltage, your letter V is. You see that?
Mm-hmm.
That's DC and that's AC. So you don't need to set it for AC or DC. Just set it on volts. Okay?
What about the low Z? What's that?
Low Z. Now you gotta look in your paperwork.
I after the volt.
Yeah, I see that. I don't know what low Z is. Look at your paperwork and it'll tell you what low Z is. All right, the next one, if you're checking continuity. Now, what do we mean by continuity? Y'all heard that term before, right? Continuity? You heard that term before? Continuity. What does it mean? Yeah, continuity. 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 You're not sure? Come on, somebody help me out. What does that word continuity mean?
That there's no break in the,
I don't know what's going on. Somebody's supposed to come online with this. What was that, Ms. Wilson?
that there's no break in the,
There's no break in the circuit. It's a complete circuit. That means everything is okay if you have continuity. All right, that's what you want. You want continuity. You don't want any break in the device, no break in the wires or the line. You want continuity. So this will, and we'll show you in a minute how to test for continuity. This is very, very important in air conditioning. We told you in the beginning, the majority of your problems in air conditioning is electrical. This here is the heart of your troubleshooting aspirations right here. If you don't have this, you lost in troubleshooting. You can't find out what your problem is. You be sitting there scratching your head and wondering what is going on. But if you don't have this, you just will go back home. It's not going to do you any good. All right? So you must have this, and you must know how to operate this. All right? So when you gentlemen get your meters, I'm giving you a little general information about how to, how these things work. Yeah. And here again, the other symbol here is the audio symbol. When you have continuity, that sound, you get a beeping sound, and it will let you know that there is continuity. All right? You get that audio sound. Some have this audio along with the ohms. You see this symbol called ohm symbol? I'll write it up on the board here. That's not a good artist, but that's the symbol for ohms or resistance. Okay? And when you check in continuity, that's where you set it on, that particular side. Okay, the next one is the one that we told you should have and must have if you're doing HVAC work. It's the capacitor tester, capacitor symbol. Now, why did I say that? Why do I say you should have one to test capacitors?
we have the capacitor in the,
What was that?
we have the capacitor in the condenser and stuff.
Yeah, you've got a capacitor in the condensing unit, but what else? What is that? What? Because we told you that the capacitor is probably the number one thing that will go out in your unit. It's probably the number one thing that will go out. There's a capacitor here. I don't have my glasses on, so I can't see it. There is. Where are my glasses? You know what I'm saying? And I'll show you where a capacitor looks like for AC. Oh, we put them all in there. Crate. And these are your capacitors, class. Very, very important to know and understand what a capacitor is. The basic job of the capacitor, and I like to keep it simple. There are a lot of other reasons that you might read something about the capacitor does this, does that. But the basic job of the capacitor is just to give that boost to start a motor. All right, that's all it does. It gives that extra boost to start a motor. That's what this capacitor does. And this is run start capacitor. Some people call it a dual capacitor. Okay, but this is, and if you see this, if you're doing troubleshooting, you see something like this, don't waste your time putting your meter out testing. Do not waste your time. Because if it swell up like this, you know that the capacitor is bad. Okay? You know it's bad. But if it looks like this, say, okay, I'll test it. These are the ones you will find primarily in your blower motors. These were the ones you find in your blower motors. These are the type you will find outside in your condensing units, especially this one here. Okay. And I'm going to show you another one that we have that's not swelled up. But there's another different type of capacitor. And the capacitor has, let me show you this. A measurement of 25 UF. UF is like the radian. You hear that? So those two letters UF. That's just the radian. What it's supposed to be. Okay. And then it has the voltage. This is 370 volts. 370V. See that? 370V. All right. Let you know the voltage. And but the ones you will find primarily in your condensing units, primarily, is this type here. All right. This type has fan, perm, and common. Yeah, the condensing unit. All right. Now, we'll come back to that in a minute. But these are the ones you will find in the majority of your condensing units. And it has fan. How you go? Come on in, young man. You in the right place?
Yeah,
You sound like Mr. Sidney.
Yeah, I don't know.
All right, all right. Have a seat somewhere. Okay, so we'll go back to this particular capacitor, and the reason why we ask you to make sure that you have a capacitor symbol on your meter is because these are some of the biggest problems in your air conditioning systems, clients. When you're troubleshooting, somebody call you up and say, look, my outdoor unit is not coming on. Nothing is coming on. All right? This is one thing you check. First thing you have to check is what? Power. Make sure you have power coming to your outdoor unit. And where do you check the power? Where? At the panel box? What did you say?
And the main circuit, you can check out
Where?
the main circuit,
The main panel? Where else would you check?
We said the condenser, right?
Yeah.
The disconnect.
All right, very good. The outdoor disconnect. That would be my first thought. All right? Because you're already outside. All right? Now, if you go to your outdoor disconnect, in yesterday's class, we went downstairs in the lab and we showed you the term line and load. Am I correct? All right, so what do you check if you're checking for power or voltage on the outdoor condensing unit?
Hold up, repeat that one more time. Back on.
All right, this is an outdoor condensing unit. What do you see there? All right.
What's that called again?
The word line and the word load. All right. So which side would you check first? It might not even matter. But you check the line side first because that will let you know whether you have power coming here. All right, that lets you know, okay, I got power coming to this here. Now, and then you check your load side. Your load side is just the side that's wired to the condensing unit itself. All right. Now, next week sometime we'll come up. You know, somehow we're not giving anybody.
Yeah, that's it.
And I can they will.
You did the wrong one. You went here. This is your HVAC.
And Ms. Jones said Mr. Scales was trying to get in.
Yeah, they took you back to color already. So hopefully they'll answer.
Okay, good. Okay, so, but this is one place where you can check if you get a call for no power. Okay, you will get those calls. Trust me. When somebody says I don't have any power, nothing outside is coming on. All right, so we'll go over that again about how to check from the beginning for no call for no power. All right, but this is your outdoor disconnect. All right. This is your outdoor disconnect. This is a brand new box. All right. This is what is called a fuse disconnect.
And we talking about how to turn off the power.
No, not how to turn it off. How to check
Check it out, man.
for power. You check. You get your voltage meter. All right. You get your voltmeter. This is 240 volts. All right. This is 240. It's not 120. This is 240. So you check for 240. All right. You might want to check both legs. All right. One here and one here. And if you put them both together, if I check the line side on this one and the line side on this one, what should I get? If it's on, I should get 240. All right. But if I go from one to ground, let's say where's it go ground? Okay, right here. What should I get? 120. Very good. All right, now the last thing on this, next to the last thing, no, the last thing is your temperature. You can check temperature with this. I see it's Celsius and Fahrenheit. Y'all have a real nice meter here. Real nice meter. You can check Fahrenheit with this stuff. Okay. So, let's do this real quick.
How does this thing?
Huh? How you work?
How does this thing? Oh, I'm trying to figure out how it works.
Yeah. All right. And then you have two leads here, and then you could use if you want to test voltage. You can go right here and check for voltage. Okay. Okay, I see voltage, auto. That means it's automatic. Let's see what we get.
It doesn't matter which side you put it on?
No.
You see something?
Oh. I got 123 votes.
123, that's still good, right?
Yeah, that's what you want. 123. Now we have a 240 vote outlet in this classroom, and we'll see what we get with 240. Not getting any. Not getting anything. So somehow the power is off on that 240 vote outlet. It wasn't off last year, so somebody turned it on. Now, let me say this real quick. Have y'all ever heard of tamper-proof receptacles or outlets? You never heard of tamper-proof receptacles or outlets? Okay, now, this is important because when you use a tamper-proof receptacle or a tamper-proof outlet, you still ain't come on here?
Trades? Never heard of it?
Yeah. You're getting the students familiarized with their meters.
All right.
Yeah, so they know how to use it. Very good. But if you ever come across a tamper-proof receptacle, you will not be able to push it in like you push it in on a regular receptacle. You have to push it in a lot harder. Yeah. Like this one here, you can push it in here real easy and test it. You can't do it that. You got to do put a little pressure. The air conditioning is run on a tamper-proof receptacle, and they have these little shutters that is out, and it's mainly for children, safety thing for children. Sometimes children will go and stick something into the outlet, and you don't want that. Any of y'all have children?
Yeah.
Mm-hmm. You don't want that. Let me tell you this little story when I was a little boy. I remember this vividly. We were living in Southeast Washington over there in Great Farms, right? And I was in the bed. I don't know if I was in the crib or in the bed, whatever. I remember walking up and down in the bed, and the light bulb was out, and I stuck my fingers up in they had these little porcelain light fixtures. And with the light bulb in there, I stuck my fingers up in there, and sparks came out. I said, "Damn." But you know what? I knew automatically.
So you understand? Oh, this is just
Oh, okay.
Yeah.
Yeah. And automatically knew that something was wrong, and that I shouldn't do that again. Yeah. So that's a little story about safety. You know, always keep a light bulb in your light fixtures, even though it might not be working. You have to keep something in there because power is constantly on to that fixture. So you don't want that. And children sometimes will go up and stick something in the receptacle or outlet out of curiosity or playing. So they made these tamper-proof receptacles. And I think in D.C. it's mandatory for new construction. You have an old house, it's grandfathered in. But anything new that the city have to inspect, then they have to put those tamper-proof receptacles as part of the equipment. Okay. Did you find out what low Z is?
Low resistance.
Low resistance?
Uh-huh.
Oh, really?
There's low resistance voltage measurement.
Okay. Now, when you get your meter, you test the resistance. You always make sure your meter is working okay. When you touch the two leads on audio, to let you know, okay, you're ready to go. Now, we're going to test a few things in the room here, and then we're going to move on here. All right, we're going to test these fuses, class, and see if they work, if they're any good. All right, these are fuses. There are different types of fuses. You have those round ones. I know most of y'all are familiar with those round ones here. These are your plug-in fuses, or screw-in type fuses. Use them a lot for your old service panels.
They still have those on now?
Yeah. Some houses still have them. Trust me, I've seen them in old houses. All right, so we're going to test to see if these fuses are any good. Okay, so that one is good. All right.
That's for the
Set your meter.
resistance.
Yeah. Low. I got it on low resistance. No, I got it on the audio. Audio.
No, that's
You can put it on audio. It'll test. Kind of do what
It's
you automatic.
actually measuring the fuse.
This is audio here. Okay. This is audio when you're testing your sound to let you know if it's okay. That's an audio symbol. Little music symbol, y'all seen it before, right? Many times. The audio. Yeah. See what it says here. Okay, so that particular fuse is okay. Let's check this one. Can y'all see me out there? All right.
When you put it in the only one that is set, is 01.
There's no number on there.
Huh?
There's no number on the button.
Because
Let's see yours?
Uh-huh.
No number.
What is this?
Oh, I'm sorry. I thought you were saying
No.
on this dial here. Okay. Yeah. All right, let's see if this fuse is any good. So we don't get any sound, but what does that tell you?
No good.
Huh?
No good?
No good.
Oh.
All right, so this one is good. All right, let's see about this one. This one come out of Service panel. My son used to run a bakery in Southwest DC, and I used to do his work. But this was a fuse that came out of that panel. So what does that tell you?
No good.
It's no good. All right, the fuse is no good. If it was good, we'd hear the what?
The beat of the sound.
We hear the